Okay, hello Algebra 2 for AP friends. Today we're going to be doing some examples on how to solve by the square root property or completing the square in section 5.7. So here's our first example. Solve the following quadratic equation by the square root property. So in order to solve by the square root property, we need to have our squared quantity completely isolated. So this x plus x squared needs to be isolated, so I'm going to get rid of everything else. First, by getting rid of this divided by 3, by multiplying the whole equation by 3. So that's going to become 4x plus 6 squared plus 2 with the 3 on the denominator being gone equals 3 times negative 2 is negative 6. And now again, I just need to get my x plus 6 squared isolated. So I'm going to subtract 2. And that would become 4x plus 6 squared equals negative 8. And then finally, the last step to getting my squared quantity isolated is to divide by 4. So x plus 6 squared equals negative 2. Okay, so now we're going to apply what's called the square root property. So in order for me to cancel the squared quantity here, I would have to take the square root of both sides of my equation. Now you have to be very careful here. When you take the square root of x plus 6 squared, I know it becomes an x plus 6 because the exponent when you divide it by 2 is just 1, but you have to apply the even, odd rule. Even, odd rule here. So I'm taking a square root, which is an even, of a square power, which is also even, and my answer comes out to be x plus 6 to the first, which is odd. So I have to have absolute values around the x plus 6. Please make sure you remember to put those. That equals the square root of negative 2. That can be simplified to I root 2. And now if I want to solve for x, just like any absolute value equation, this should be broken into two cases. Or instead of breaking it into two cases, I'm just going to write x plus 6 equals plus or minus I root 2. So that's pretty much the same thing as breaking it into two cases. I'm getting rid of the absolute values by putting plus or minus I square root of 2. And for my final step, I'm going to get rid of the positive 6, so it'll be x equals negative 6 plus or minus I root 2. And that would be my solution. You can write it in set notation like negative 6 plus minus I root 2. So this quadratic, since it is a quadratic squared, it has two solutions. One of them is negative 6 plus I root 2, and then the other one is negative 6 minus I root 2. And that's how you solve by the square root property. Our next examples, we're going to be solving by completing the square. So, example 2, solve the following quadratics by completing the square. Okay, so in order for you to complete the square, you always have to take the linear term, which is this negative 8, divided by 2 and square that. So if I take the 8 and I divide it by 2 and I square that, that's going to give me 16. So that's what 16 is what I need in order to complete the square. So I'm going to write down x squared minus 8x. And then I'm going to complete the square with doing a plus 16. And then I keep writing the rest of the problem, which was a plus 11. Now, since I did just add a positive 16, I have to subtract that same quantity so I can keep this equation balanced. So that right there is called completing the square. Take your linear term, divide it by 2. Technically, it was a negative 8, but it's still going to be a plus 16. Take your linear term, divide it by 2, and square it. So that's going to be a positive 16, and then you have to subtract that 16 to keep the equation balanced. So now the next steps in completing the square is just to factor this perfect trinomial into x minus 4 squared. Simplify 11 minus 16, so that's negative 5 equals 0. And from here, you would just solve by the square root property, like I showed you in example 1. So let's get this x minus 4 squared isolated by getting rid of the minus 5 and putting plus 5. Take the square root property on both sides. Always, when you take the square root of x minus 4 squared, always write it as absolute value of x minus 4 equals just the square root of 5. Make sure you always show that step. And now if I do want to get rid of the absolute value, it would just be x minus 4 equals plus minus, so that gets rid of the absolute value, square root of 5. And then to solve for x, my final answer would be x equals 4 plus minus square root of 5. And we can write that in set notation like 4 plus minus square root of 5. So again, this quadratic has two solutions, 4 plus the square root of 5 and 4 minus the square root of 5. So our last example, same thing, we're going to do it by completing the square, but it's a little more fun. It has a coefficient of a 2 in front of your x squared, so just like you learned, when you complete the square, the coefficient of x squared has to be a 1. So the first thing I'm going to do with this question is I'm going to factor out a 2 from the 2x squared and the positive x here. So I'm going to do 2 parentheses x squared plus 1/2 x, because 1/2 x times 2 gives me that positive x. And then I'm going to leave a little space here to complete the square. The minus 15 can stay as minus 15 equals 0. So now I need to complete the square. So remember, to complete the square, we need to take the linear term, so 1/2, divided by 2 and square it. So if I take 1/2 divided by 2 and square that, 1/2 divided by 2 is 1/4, and if I square that, that's going to be 1/16. So plus 1/16. And now remember that I need to keep this equation balanced, so I need to subtract, but you have to be careful. We're not going to just subtract the 1/16. We have to multiply our 1/16 times the coefficient of 2. So that is a 1/8. So that's what I'm supposed to subtract. I'm supposed to subtract 1/8 to keep the equation balanced. So now I can get ready to factor this. That's a perfect square trinomial, and it would factor into x plus 1/4 squared. And now we need to correctly subtract the minus 15 minus 1/8. So simplify those and combine them. If you do it correctly, that should give you a negative 121 over 8. That equals 0. And then you just continue solving this by the square root property. So I'm going to get rid of the minus 121 over 8 and move it to the right side. So it'll be 2. Parentheses x plus 1/4 squared equals 121 over 8. Get rid of the 2 by dividing both sides by 2. So x plus 1/4 squared equals 121 over 16. Take the square root of both sides. This is going to give me always an absolute value. X plus 1/4 equals the square root of 121 over 16. Those are both perfect squares, so that's going to be 11 over 4. And now I can get rid of the absolute value by doing x plus 1/4 equals plus or minus 11 over 4. And then for my next step, move the 1/4 to the right with a negative 1/4 plus minus 11 over 4. Now, you can't leave your answer like this because these are like terms. Like I need to combine those. Previously, you had like a radical. That can't be combined with an integer like that. So those were not like terms, so I left them like that. Here you have a 11/4 and a negative 1/4. Those are integers, so you do need to combine those. So I am going to go ahead and split this into two separate answers. So negative 1/4 plus 11 over 4. That's going to give me one answer. And then the negative 1/4 minus 11 over 4 is going to give me my second answer. So negative 1/4 plus 11 over 4 is going to be 10/4. So that's 5/2. That's one of my solutions, or x equals. And then negative 1/4 minus 11/4 gives me negative 12/4. So that's negative 3. And you can write your answer in set notation, 5/2, comma, negative 3. And that's how you solve a quadratic by the square root property and by completing the square.